go. Lesson 1.2, final day. This is the 6th day I've recorded, plus we had a day in there where I didn't even do a recording. So this is literally our 7th day on lesson 1.2, I think. But I've been doing material every day. There's that much material in lesson 1.2, which I know is crazy to think of. So, okay, yesterday at the end of class, we were talking about even and odd functions in symmetry, right? We did our first example. We plugged in, we found f of negative x. Every place you see an x, you replace it with negative x. We found them to be the same. If f of x equals f of negative x, it's even. The symmetry there, if it's even, it's symmetric across the y-axis. Okay, then we went on to b. When we looked at b, we plugged in negative x, and g of negative x is not equal to g of x. So because g of x and g of negative x were not the same, we knew it was not even. We could not stop there, though. We had to go another step. So then we found negative g of x, which means multiplying the whole equation by a negative. And notice, the question is, does negative g of x equal g of negative x? And those two are not equal, so it's not odd. If it's not odd, it's not even, it is neither. I think in your class I graphed it, and it was a parabola, but it was like not centered, right? So it wasn't symmetric in any way across either the origin or the y-axis. So now we're ready for C. Yeah, we can already predict the answer, but we need to understand why, right? Both algebraically and graphically, even though you already know what the answer is going to be. So, what are our steps? The first thing we're going to do is we're going to find h of negative x, right? Every place I see an x, I'm going to replace it with negative x. So instead of x to the third, we're doing negative x to the third. Instead of 4 minus x squared, it's 4 minus negative x to the second. Okay. What is negative x raised to the third power? Negative x to the third, because a negative raised to the third is still a negative, isn't it? So it's negative x to the third. 4 minus, what is negative x raised to the second power? X squared, right? Now note, it was already 4 minus that, so it's going to be 4 minus x squared. So right here, the negative of x cubed over 4 minus x squared, this is our h of negative x. What do you know about h of x and h of negative x? They are not the same. Since they're not the same, at this point we know that this equation is not even. Okay, so what do I have to find now? Now we're finding negative h of x. And when we find negative h of x, that means you're taking the whole function and multiplying by a negative. Now, the difference here is my whole function is a fraction. And so there's a couple different ways we can think about this. When you multiply the whole fraction by a negative, I'm going to put the negative out front. The negative of x cubed over 4 minus x squared. You can think of it as like multiplying a negative 1 into this fraction. When I multiply a negative into a fraction, do I multiply top and bottom by negative? Because what is a negative over a negative? A positive, right? So if I multiply top and bottom by a negative, I'm really multiplying by a positive. So to multiply by this negative, the negative can go with the top, with the bottom, or out in front. Let me say that differently. It can go with the top, or with the bottom, or just out in front of the fraction bar. But you only put that negative one place. Now, when we put that negative one place, what do you see? Where would be a good place to put it to make it look like the top one? It becomes negative x cubed over the still 4 minus x squared. And so what do you notice then? H of negative x and negative h of x are equal. Based on the algebra, if they're equal, what do we officially say? It's odd. What kind of symmetry are you going to expect to see? Origin symmetry. So this is going to be symmetric across the origin. Now, and you may be saying, what the heck does symmetric across the origin mean? Well, let's graph it. X a third over 4 minus x squared. Zoom 6, because I don't know what I last zoomed or graphed yesterday. Okay. I'm not going to ask because you guys don't really know. I'm going to tell you. This graph is symmetric across the origin. Okay? What I like to think of when I'm trying to test if something is symmetric across the origin is if I pick just one quadrant and I take that quadrant and I reflect it across both axes, does it land on top of an equivalent quadrant? Does that make sense? Okay, so like if I take this bottom right quadrant and I flip it up across the x-axis and then I flip it across the y-axis. Is that curve? Any quadrant. Now, we could also do it with, you can do it with the whole graph, obviously. But that's like how my brain works best. Is okay, if I take quadrant 1 here, and I reflect it, say, across the y, and then down across the x, notice it lands on what's already there. Okay? I believe symmetric across the origin, I believe, is also equivalent to a 180-degree rotation, if I'm not mistaken. So either of those ways you can think of that equal something symmetric across the origin. Now, if you're kind of unsure about that, that's why we also have the algebra to back it up. Okay? Questions there? No? Okay. So, one of your topics in homework will be even and odd functions and symmetry, or one of your sections. Okay, asymptotes. Asymptotes are not totally new to you. I did teach these in Algebra 2. Okay, when we had the test, you had a little half sheet that had the asymptote information on it, if you recall. Okay, so you've learned asymptotes. I'm not saying you remember them, but you have learned them. So, let's review. Vertical asymptotes. We've talked about vertical asymptotes lately, right? And vertical asymptotes are places that make the denominator equal to 0. Okay? In order to find a vertical asymptote, you're going to set the denominator equal to 0. Okay? So vertical asymptote, set those denominators equal to 0. Horizontal asymptote. It's more of a if this or that, it just kind of depends. You have to look at your biggest power. Okay, so it's all about the biggest power. If the biggest power is on top, then notice there are no horizontal asymptotes. Okay, if your biggest power is on top, there are no horizontal asymptotes. We'll talk a little bit later about something else, but there's no horizontal asymptotes. If the biggest power is on bottom, then y equals 0 is always the horizontal asymptote, if the biggest power is on bottom. If the powers match, so your biggest power on top and your biggest power on bottom match, then we use the coefficients of the biggest powers. Okay, so that's if the powers match. Let me show you an example of each of these real quick. X cubed plus 1 over x squared minus 2x. Sorry, you guys can't really see that. Well, and besides the fact I kind of got it botched there a little bit. Let me see if I can unbotched a little bit. Is that such a thing? Yep. To unbotch something? That looks a little bit better in my opinion. Okay, so what I wrote next to, this is the top row, x cubed plus 1 over x squared minus 2x. What do you notice? This is an example where bigger power's on top, so there would be no horizontal asymptotes. Okay? An example for biggest power on bottom. Well, if I flipped this, if I instead said x squared minus 2x over x cubed plus 1. Okay, that's an example where biggest power is on bottom. So biggest power on bottom, then we have y equals 0 is always the asymptote. Now, I want to show one that's matching. I'm just going to put it right here. If I show one that's matching, 3x cubed over 4x cubed plus 1. What do you notice? The biggest powers are both 3. So it says to take the coefficients if the biggest power match. What do I mean coefficients? What are the coefficients of the biggest powers? 3 and 4, right? And so in this case then our horizontal asymptote would be y equals 3/4. Okay, so it's all about those biggest powers. What's going on with those? And that will give you horizontal asymptotes. Now, our example for this section. Determine any horizontal or vertical asymptotes of the given graph. Thoughts on where to start? Okay. So, in terms of horizontal, the biggest power is on bottom, right? We have an x to the first as the biggest power on top, x to the second on bottom. Since the biggest power is on bottom, what's that mean my horizontal asymptote is? Y equals 0. Okay? So there's horizontal. Now, let's also check vertical. Thoughts on vertical? Okay, set the denominator equal to 0. So that means in this case I'm setting x squared minus x minus 2 equal to 0. What do you notice about that denominator that I just said equal to 0? Or what do we hope it happens? We're going to hope it factors, right? Because if it doesn't factor, this problem's a lot more difficult than we want it to be. But hey, guess what? It's going to factor. You know how to factor this, right? X squared breaks up into x and x. What kind of numbers? Did you say 1 and 1?
Yeah, but 2 and 1.
Yeah, 2 and 1. If it's going to multiply to be 2, it's some combo of 2 and 1. If it multiplies to be -2, one of them's negative. If it adds to be -1, larger one's negative, smaller one's positive. Okay, so x minus 2, x plus 1 is what it factors into, and of course you set each part equal to 0, right? X minus 2 equals 0, x plus 1 equals 0, and so we know x equals 2 and x equals -1, correct? Now, I left some room to the right because I want to sketch this graph. Okay, now, I don't remember exactly what's in homework, but I want to sketch this graph, and with my help, we can sketch the entire graph without even using the calculator. Okay? How you guys don't have quite all those skills yet. You have some of the skills, but you don't have all the skills yet. Okay, so we're going to, I just kind of want to show you how this all goes together here. Okay, so I'm using my remaining space to make a graph there. I'm going to draw in some pieces here. Horizontal asymptote of y equals 0. Where is the horizontal line y equals 0? It's the what? Not the y-axis, the x-axis. Because y equals 0 whenever you're on the x-axis. So right there, there's a horizontal asymptote there. Okay? Horizontal asymptotes, remember I just used a dotted line to show them. I just kind of put it right there, tried to put on top of the x-axis. Okay? We have vertical asymptotes at x equals 2 and x equals -1. So what do I need to do here? I'm going to count over to 2 and count over to -1, and I'm going to put vertical asymptotes in, which are basically little dotted lines, right? Now, this is where, okay, vertical asymptotes, my graph is never going to cross the vertical asymptotes. Okay, and I know some of you guys have already graphed this, so you know what the graph is going to kind of look like anyways, but this is kind of, you know, putting it all together. My graph is never going to cross vertical asymptotes, ever, at all. Okay? So my graph will run up along beside them and stuff. Horizontal asymptotes. Okay, so horizontal asymptotes we talk about in behavior. My horizontal asymptote means my graph will never cross the horizontal asymptote as it goes off to the ends. Now, it can cross, your graph can cross the horizontal asymptote in the middle of the graph, just not as you go off to infinities. That horizontal asymptote will show us what our graph's doing as it runs off to infinity. Now, the part that, you know, some pieces that you don't really know is where to start and everything. So my horizontal asymptote, my graph's going to be running alongside of it as it goes off to the ends. Because this is a positive graph, right? It's positive x and positive x squared. We're actually going to start on the top side of the graph. And what's going to happen, so we're on the top side of the graph, and we're going to be running along the x-axis. And then eventually, as we approach that first vertical asymptote, what's our graph have to do then? It's going to curve and go up. It's going to curve and go up because it has to run along that vertical asymptote, right? Now, a vertical asymptote that just has a, you know, this just came from a factor of 1. When you cross over a vertical asymptote, your graph switches from positive to negative or negative to positive. Right here, my graph is positive because it's up top, right? So if my graph switches, it's now going to be down here. I forgot to talk about something, didn't I? Okay. It's going to be down there. And, yeah, I forgot to talk about zeros. But because there's an x on top, I guess I didn't think about to talk about this ahead of time. That also tells me that I'm going to have a 0 at x equals 0. And so my graph is actually going to cut through. It's going to kind of snake up over here and cut through. Notice it's running along my asymptote at -1 then. So it starts by running along an asymptote 2 and then runs along an asymptote -1. We've got another vertical asymptote, yes? Another vertical asymptote, which means my graph ended positive here. Guess what? It's going to now be negative. This one, I have no reason to cross the horizontal asymptote, so it stays down below it. Okay? As I said, am I expecting you to be able to put that all together as a graph? No. But I think it helps to be able to put the asymptotes on and those type of things. If I look at, some of you have graphed this, haven't you? My graph should be similar. It's just going to be the calculator version of it. Similar to what we had. Okay. So again, it's not that I expect you to be able to put that all together. You can use the calculator to put that all together. However, you should have known where your asymptotes are, right? Those should match up. Things like that. Okay. More importantly right now, can you find your horizontal and vertical asymptotes? That's more importantly what I need you to be able to do as a skill on your own. Okay? Putting the graph together, no. But I think it's kind of cool to see how it comes together. Okay, questions there? The air conditioner can't decide if it wants me to talk quiet or loud today. Okay, one last topic. In behavior. Now, a little bit, we've already talked about in behavior a little bit because we talked about horizontal asymptotes. I talked earlier that a horizontal asymptote, if you look at this graph up here, notice it's leading my graph along the x-axis. So is this one, it will never cross above the x-axis over here left. Over here right, it will never cross below the x-axis. So that is in behavior. So our horizontal asymptotes determine in behavior. So here, as you notice, in behavior is what is happening on the far left and far right of a graph. So basically, as x goes towards negative infinity and as x goes towards positive infinity. If there's a horizontal asymptote for the function, it will be approaching that number. So like we had a horizontal asymptote of 0. That means my in behavior, my graph is approaching 0. Y equals 0. If the graph is going to infinity or negative infinity, then it will approach that value. Okay? So, when you look here and it says determine the in behavior of the function, my recommendation is that we are going to think horizontal asymptotes. Okay, so think horizontal asymptote here when it says determine the in behavior. Because if there is a horizontal asymptote, that is my in behavior. So as you look at A, what do you see when you look at A in terms of horizontal asymptotes? Y equals 0. Okay, biggest power's on the bottom, right? If you look at the idea, we're comparing 3x and x squared. And if you want to, you can think about there's an x in common that can cancel. And then you're looking at 3 over x. And think about this. As your x values are getting really big, 3 divided by a bigger and bigger number. Well, the bigger that number gets on bottom, the closer we're going to get to 0. And so we have in behavior, or horizontal asymptote of y equals 0. Kind of like the graph we just looked at. Okay? If I throw this on the calculator real quick. 3x over x squared plus 1. Notice, oops, sorry, I'm off the screen a little bit here. What is my graph getting close to or running alongside as it goes off to the left and off to the right? It's running alongside the y-axis, yes, which is 0. Excuse me, the x-axis. Okay, here it's on the negative side, here it's on the positive side, but either way it's getting closer and closer to that y value of 0. Okay, look at B. Y equals 3x squared over x squared plus 1. Thoughts on this one? Okay. My biggest powers are both x squared, aren't they? It's 3x squared and say 1x squared. You look at those biggest powers, yeah, we're looking at the coefficients because basically the x squared's canceled. 3 over 1, which is 3. So we have a horizontal asymptote of y equals 3. Okay, so my graph now, if I show the graph real quick, I just changed it, 3x squared over x squared plus 1. We have this V-like shape. I don't know, reminds me of a bird you might draw or something, just with really long wings. Or what? Okay. Yeah, when you have it open. I see the book option. I see it. Okay, here's the deal. Okay, so if this is a book laying open, you know, whatever. What do you think? What is the top of this graph running alongside? If I start trace, guess what? My y value is going to get really close to 3. It's never going to cross 3, but it's going to get close to 3. Okay? And so that is my end behavior of y equals 3. As my graph goes off to the left and right, it's getting closer and closer to 3. Okay, C. What do you notice on C? Biggest power is on top. So 3x cubed over x squared, biggest power is on top. Based on what we learned up above, what do you know about horizontal asymptotes? There are no horizontal asymptotes, right? So, side note, no horizontal asymptotes. Now, technically, I'm not quite done though, because is that what this section was asking? This section wasn't officially asking what are the horizontal asymptotes, because if so, okay, I could say none and be done. But it's asking about in behavior. So, if you think about kind of what I've been doing with the others, if I cancel stuff, 3x cubed over x squared, what's in common that cancels out? X squared cancels out, right? So if x squared cancels out, I'm left with 3x over 1, which is 3x. Okay? Your end behavior is going to run along the line y equals 3x. This graph is going to have what we call a slant asymptote. Can you visualize the line y equals 3x? What's the line y equals 3x? It has a slope of 3, so rise 3, run 1, and a y-intercept of 0. Okay, so this graph, when I graph it, is going to be running alongside of this. Okay, so this is what we call a slant asymptote. And it will make perfect sense when I put it here on my graph here in a moment. So let me adjust. Let's see, now it's 3x to the third over x squared plus 1. Oh, I did not recenter my graph. Oh well. So, do you see that diagonal slant there going on? The idea that as this graph, as our x values are getting smaller and larger, going out in the ends, where are our y values going? Well, they're running alongside that diagonal line, y equals 3x. And just so you can kind of see, let me graph the line y equals 3x for you. Zoom 6 and recenter this. Okay, so there's my original graph. And then, does that match up with that red line pretty well? Yeah, that red line is y equals 3x. That would be equivalent to like an asymptote. Okay? Probably if I played in my settings, I might even be able to make that a dotted line. I'm not sure, but. Okay, so in behavior, you're looking for the horizontal asymptotes. What's it doing? The only difference is if there is a bigger power on top, there is still in behavior. Okay, your homework, if you haven't already written it down, haven't started it, is, I think it still officially starts on page 95, 48 through 66 evens. Okay? You have a few brief minutes here. You could start looking at it. That homework is due on Monday. Okay, due on Monday. And we'll talk about on Monday. Now, with that in mind, tomorrow is e-learning day, yes? The post will be on Schoology with all the information. But while you're in class, and I'm going to leave my recording going in case anyone at home watches this, if you flip the next page, has anyone flipped the next page in their notes? You have this page right here, yes? Yeah. It's just a front side. But notice it says section 1.3, 12 basic functions here, yes? Okay. We will go over them in class, don't worry. But here's your job. I want you guys to do some of the base work. Meaning, you have a graphing calculator, yes? What I want you to do is I want you to graph these on your graphing calculator and try and start sketching them in on the graphs. Now, some of you are very particular about your notes, aren't you? So, if you're particular, you can do them in pencil where you can easily erase it and change it. If you really want to, you could do this on a separate sheet of paper and wait and fill in the actual notes when we go through it in class. It all kind of depends on where you are. Okay? I also notice underneath each one it says domain and range. I want you to make an attempt at what you think the domain and range might be once you look at the graph. Okay, so take your graphing calculator, graph the 12 of these, sketch what you think the graph looks like based on your graphing calculator, fill in the domain and range as well. Does that make sense? That's your e-learning assignment. Okay, so right there it says lesson 1.3, graphs, domain and range. You don't have to go past this first page of notes. You just have to look at that first page of notes. Okay, and as I said, I'm still going to go through and teach them. But the lesson goes a whole lot differently if you guys have some previous insight. Now, are you going to get all of them perfectly? No, which is why I say do them in pencil if you're doing them in your notes. Okay? So, that is your e-learning. That will be due Monday. I am torn with, do I want you guys to take a picture and submit them to me? Or do I want you to just show them to me in class? Huh?
No.
What, show them in class?
Yeah. I don't care if we're going to
Huh?
I don't care if I got to upload it.
This is hard. Upload and I
Oh my gosh, seriously. That's the easy work if you have to take a picture and upload it. Okay, well, I'm torn right now which way I want assignment will say so. Does that make sense? I'm have it ready to go.
Well, if we do Monday, or if we do the picture, you want to do Friday?
No, you could still wait and submit it Monday.
I have 2 questions about it. The time calculator. Well, okay, I think I noticed that one. But where's like the little E thingy at?
It's there somewhere. It's one of your second functions on your buttons. You don't even have to go in.
It's the symbol.
There's also an E to the X over above your LN button.
It's the division one.
Yeah. So again, this is part of the challenge is figure out how to enter these on the calculator, isn't it?
And then on the bottom middle one, it's like the 2 little brackets. Can you just use like the second?
We'll have to talk about that one on Monday, really.
Okay.
There's more to that one. I will say, can you guys read this bottom one? Logistic function.
Yeah.
If you can't read that, that is y equals 1 over 1 plus e to the negative x. And again, I'm not grading this on total correctness, right? I understand some of your graphs aren't going to be exactly right for various reasons. And some of that is knowing how to use the calculator and whatnot. I get it, okay? So, I'm not grading this on correctness. I'm grading this on effort. Make sense? So, I will put in the Schoology assignment. I honestly might have you go ahead and submit them on Schoology. I would not have to have those tomorrow, though. Okay? I would want them Monday before class starts, though. Because if Monday we start going through them, I can't have you submitting them after we go through them in class. Does that make sense? So, but I would not have to have them tomorrow.